to talk about Ethereum. Ethereum is next generation smart contract, decentralized application platform. Actually, I didn't really know where to start with this group, so I just went really basic. All right, so take you back to 2008, 2009. Satoshi Nakamoto is coming up with ideas for Bitcoin. So Satoshi had two really big ideas that he wanted to test. One was the blockchain. A blockchain is this secure, decentralized database. It uses a mechanism called proof of work to precisely and chronologically order all entries into a ledger. And it does this without any central authority. Next thing he wanted to test was transactions. He wanted people to be able to move money around. All right, so these are two really big ideas that he wanted to test. So he went ahead, made Bitcoin. Fast forward, success. Not because it's got a $12 billion market cap, not because it's growing in popularity, but because of the protocol. The protocol works. Okay, so anyways, I don't know how many people here are into altcoins, but now we have a lot of altcoins. Maybe you've probably heard of Dogecoin.
Dogecoin.
Yeah, yeah. We have a lot of them are Bitcoin clones. They actually just use the Bitcoin code. What they often do is they use tweaks or modifications. They change the proof of work algorithm. They maybe mess around with the distribution model. Change the inflation or deflation. Okay, and then we have some blockchains that offer other services. A popular one is Namecoin. It's got a $50 million market cap. It's a cryptocurrency, but it's also a DNS service. So when you go to your browser, you type in jeremy.com. It asks for information from somewhere. It says where's this server at, and then you get the IP address back, and then you can go to the server. So that involves a third party. Problems with that is man-in-the-middle attacks. Also, censorship is a problem. All right, so this is with the blockchain. All right, so has anyone heard of colored coins? Just one? Oh, okay, so this is good talking, okay. All right, so colored coins actually sits on top of the Bitcoin blockchain. What they do is they take Bitcoin or a fraction of a Bitcoin and they tag it or color it. And then, then you can use that token to represent anything. Okay? I realized late last night I probably shouldn't have gone with the ownership. I'm going to talk about a car here. It might be better to pretend like it's the future, 2020, and the car is also smart. So basically, yeah, you can take the smallest bit of a Bitcoin and you color it and you say this is your car, okay? And so then you have ownership of that. It's in the blockchain, it's stored in the blockchain. You can go farther with this. You can actually add information into it too. So the token also knows what make and model it is. And if the car is smart, you can also the car could actually talk to it too and put in mileage and maintenance information and stuff like that. And then your car is smart and it says, "Are you my owner?" And so yeah, all you have to do is prove that you are the actual owner. All right, these are called smart properties. There we go. Sorry guys, I don't do many presentations. Anyways, you can also represent a house. You can do anything like that. Stocks and bonds. You can issue your own stocks and bonds. It can represent gold or silver, any kind of asset. You can use these for trading. You can actually make your own currency using this model too.
Can I ask a question?
Yes.
With the car example?
Yeah.
Do you mean that the car challenges you for your I guess, private wallet key?
Right. It would challenge you.
Like a password login
Right.
thing?
Wait.
Okay.
Right. So private key, public key.
You gonna carry your private key around with
You could in your smartphone.
you? Really?
Yeah. Well, I mean, yeah, you can. The car can challenge you. You can use a password. It's possible.
Okay.
You mean that it would be beneficial to send something like this up to check identification people? Is that what you mean? Like, I can't tell if it's a metaphor or is there going to be a car that this is implemented in?
That's a good question for the end.
I'm just confused.
That's a good question for after we finish.
Yeah. All right. So
It's a long answer, I think.
Yeah. Sorry. So yes, like I said, I should never use this car example, but I wanted to connect it with the smart contracts. Okay. So you do have if you have this token, it's your car. You have it. It's yours. You're the owner of that car. With smart contracts, you can do some interesting things. I put a little disclaimer here. Don't try this at home. You can actually see it all, but so that with the decentralized systems. Bitcoin actually provides a foundation for trust. So what I think is interesting is that you could have done smart contracts a long time ago, but if you're just on your computer or a central server, there's no trust that someone's not going to hack into there, change the program, or the owner's not going to change the program. Smart contracts are just programs, but on a decentralized computing system. They are more secure. Okay. So with the smart contract, basically you can take the token. Let's say you want to sell your car. You put it into the program, and it just sits there. And then when someone wants to buy your car, they can transfer the funds into the contract. Then the contract would release the token to the new owner and release the funds to the previous owner. Okay. Also, you could do payment systems with smart contracts. You can put the car token into a contract, have people make payments. Once payments are completed, the contract releases the token. Okay. Collateral, you can use your car for collateral for a loan. Put that into a contract. All right, so yeah, what I've been talking about are Metacoins. So Bitcoin has a blockchain, it's a ledger. Metacoins sit on top of the blockchain. One of the analogies they use is like HTTP over TCP. TCP is the backbone of the internet. HTTP sits on top of that. But there's some problems with that. Bitcoin isn't really like TCP. It's more like SMTP, which is the email protocol. So it's not exactly, you wouldn't want to put HTTP over SMTP. SMTP is really good at what it does. It's a really good email protocol. Bitcoin's a really good protocol, but putting things on top of it has problems. One of the biggest issues, though, is fragmentation. There's a lot of different systems. There's colored coins, there's master coin. It's all over the place. They don't work together. Okay? And so, yes, it's fragmented. Alright, so I'll talk about Ethereum a little bit. So Ethereum is a cryptocurrency. It has its own blockchain. Okay? Where a lot of the other currencies have features, like the Namecoin, a lot of currencies are always adding features. We have this feature, we have that feature. Ethereum actually, the currency is called Ether, actually strips all that away. It's feature free. Instead, what it offers is a Turing-complete programming language, and they're called contracts. Contracts are automated agents. They actually live on the blockchain. They have their own address. They have their own balance. They can send and receive transactions. They have their own memory and they have their own storage. So normally this would not be a good idea. Actually, Satoshi Nakamoto wanted to do this. The problem is it's infinite loops, resource-intensive programs. So there needs to be a way to stop this, and we do that with fees. So making contracts and activating contracts takes fees. The fees are paid in Ether. Okay, so you can make a contract that adds 1 to infinity, but as soon as it runs out of money, it stops. Okay, so it's highly regulated with fees. Right now, there's about 7 different fees. Okay. So the thing with contracts, instead of having contracts be enforced by the legal system, you can have the contracts that enforce themselves. And so I kind of talked about that a little bit with the car. So this is a basic contract. Basically, what you do is it gets the transaction, it checks the transaction to see if it has enough fee to run the contract. Then it checks to see if the data is still in there, or already in there, and then it adds data into the contract. So this is really, really basic. You can add a lot more complexity to this. But you can do mappings. Okay, so you can do mappings from names to IP addresses. So Ethereum is a platform. So a good example right now would be to talk about BitMessage. Does anyone know about BitMessage? Okay. So BitMessage is a peer-to-peer decentralized email application. Right now, though, it has a 34-character string. So if you want to email someone, you have to have this 34-character string to email them. It's a real usability problem, right? So with smart contracts, you can map just a regular name, Jeremy, to the 34-character string. So you can have a so the client actually would be able to look for this contract and pull out this information. Let's see. Multi-signature escrows. Basically, the idea here is that you can put a bunch of money into a contract, and then it takes more than one person to get the money out. Okay. You can actually do this with Bitcoin. It's different though on Ethereum. If you had, say, you needed 50 out of 100 people to authorize a transaction, they could all send it over time. So as soon as it hits the 50, then the contract authorizes the transaction and sends the money. This is an example of a savings account. Alice makes a contract with Bob. Bob is a trustworthy party. It should be something like a bank. Alice can take out 1% a day. Bob can take out 0.05% a day if needed. Okay. If Alice wants more, Bob can approve it. So Bob can use his key to release more funds to Alice. If Alice's private key is stolen, she can move the account with Bob's help. So the criminal wouldn't be able to move more than 1% out of the account per day. And if she realizes her key is stolen, she can go to Bob and they can move the account. If Alice loses her private key, then Bob collects the money slowly over time and can give it back. Okay.
Or not.
Yeah. Now, if Bob is a thief, then Alice can actually withdraw her funds 20 times faster than Bob. So she's still going to lose money, but she's not going to lose all her money. Okay. So this is an idea what you can do with the contracts. All right. So also another exciting thing that people want to do with this is incentivize data storage, decentralized Dropbox. So a lot of what you can do with these contracts is incentivize work, right? So you can ask somebody and put a fee into a contract and say, "Can you store this for me?" Right? You can pay those fees. If you want to rent out your extra hard drive, you can accept those contracts and store this data. Identity and reputation systems are really big. You can create a web of trust, decentralized Facebook, crop insurance. A lot of people are working on all the financial stuff, hedging, all that kind of stuff. And this probably should have been a bigger topic here. Decentralized autonomous organizations. Okay. With these contracts, you can basically take everything that a company does and put it into a contract. Okay. Instead of all the legal stuff that you have to go through to start a company, you can put them directly into the contracts and then create a company in this way. The basic example is basically where you just have a big fund and then everybody has a vote to allocate those funds. So you can have a majority, you could have a super majority. You can set up whatever kind of system you want. A lot of people are really excited about using these organizations to fund scientific research and things like that. All right, I think I'm finished.
Thank you.
All right.
Probably do your question first.
No, I'm cool. I get it. I get it. How long do you think before stuff like this starts happening?
Testnet comes out tomorrow.
11 hours.
Yes.
And what is
I just checked.
Oh, wait, what is that?
It's got a countdown.
Testnet?
That's going to be a centralized testnet. Yeah, so you can actually get on and write these contracts.
Okay. Wow.
And it should be up tomorrow. You know how these things go. It's probably going to be 2 days, but yeah. So actually, the testnet's going to be up.
I just realized you can make a government with this.
Yes. Yeah.
That's insane.
All right.
Can you implement the Silk Road with this?
Of course, yes. Yes.
What's the protocol for changing a contract? Or
You can. The contracts can modify themselves, and they can replicate themselves.
let's say you write your contract for the government, and then you find a bug. So how do you
Right. So then So yeah, you can actually set up the organizations so they have to have the vote to modify the code. Yeah. Yeah. So yeah.
Vectors for people getting in and messing with it. What are they?
There are some security concerns.
Yeah.
Obviously, it's going to be sandboxed.
Mm-hmm.
JavaScript had a lot of problems. There's going to be a lot of security people looking at this.
Bitcoin's got a lot of problems.
It still has some problems, yes.
Yeah.
Yeah. That was one of the reasons Satoshi Nakamoto didn't. He just gave up. He was already testing these two big ideas.
Mm-hmm.
He wanted to do this third. People have been talking about smart property and smart contracts since like the 90s, early 90s. So.
I was just wondering if I understand this with the DNS example. You're saying any kind of processing requires fees.
Mm-hmm.
So you're saying
transactions.
Transactions.
Yes.
So a DNS lookup would not be.
The contracts can look up, can actually access the memory of other contracts.
Okay.
So
and
you don't have to pay fees to actually look at the information in a contract.
Okay. And the program actually runs where physically?
It's a distributed computing system, so it's running on people's computers, and actually part of the fees do go to the people running.
Like a mining fee.
The mining, yeah, part of the mining.
Oh.
So, if it's decentralized, you mean you have access to all contracts available, how they work? Can you find out?
Yeah, you can look at the contracts, and
right.
well, obviously, because how do you know if a contract is trusted?
So even the contract that do not concern you, you can basically look at any kind of contract available in the platform. Okay.
Is there any way to hide that? For example, if somebody's not involved in a contract, and that could change dynamics of a situation if anybody can check that information. Right?
Yeah, that's true. There is no. People are. The testnet comes out tomorrow. I'm not exactly sure what kind of mechanism they're going to be able to hide information. There's actually a lot of integration going on. I don't know if anyone knows Open Transaction. There's going to be a lot that you can do with other applications and using this as a platform. Mm-hmm. So that kind of information hiding could go on somewhere else, right?
Okay, so one of the problems with Bitcoin is the blockchain getting too large.
Yes, this is also a concern here.
Okay.
The Bitcoin people are pretty positive they can solve these problems. We're pretty positive we can solve these problems. The contracts have a suicide function. Actually, I don't know the mechanics of it yet, but you will be able to recoup some of your fees, and it's supposed to encourage people to get rid of the contracts, kill the contracts.
Is it like Bitcoin where you only need like n-1 to start building a new blockchain? You don't need the history going all the way back to 0.
That's a good question. I don't know.
Alright.
I don't know. Yeah, I've been so focused on the contracts, I actually don't know how Ether's really not meant to replace Bitcoin. Bitcoin's really good at what it does. It's a money transmission system. So, yeah, but I'm sure. Yeah, it's probably it's the same. You mean like you can go back in time? Yeah, yes.
But you'll need like the last state of the blockchain plus the next transaction to go forward. You don't need the whole history as a client.
Oh no, you need the whole history.
You need the whole history.
Yeah.
Okay.
Is there anything like to 51% tax?
That's actually, I mean, that's a big concern, right? So, what a lot of people are trying to work on is a memory hard proof of work algorithm.
Mm-hmm.
This way, you wouldn't be able to build ASICs. So people are trying to work on a proof of work that can be GPU and ASIC resistant.
Mm-hmm.
That's something that we're really trying to work on. But that's still something that could be swapped out. There's one called Dagger,
Mm-hmm.
and there's a proof of stake version called Slasher. This is actually it has to be all tested. Okay,
Nope.
we're good to go.
Thank you.
Yeah, thank you.